In this video, I'm going to show you how to build a powerful data scraper for e-commerce sites using AI agents. In this tutorial, you will learn, first of all, how to build an advanced product scraper. We will build a script that automatically visits e-commerce sites and extracts the type of information that we want. How to extract data from images and PDFs. The key feature of this agent is its ability to read information within images and PDF links of the target product site that we are scraping. How to use AI for structured data extraction. You will see how to build an agent that not only pulls technical specifications from these sources, but also is able to detect the different variants of the product that you can purchase, like color, sizes, dimensions, etc. Finally, how to structure all this data. This agent will organize all the data scraped into a neat and clean format that later we'll be able to use in our e-commerce. So if you stay with me, by the end of this video, you will have an agentic scraper that can save you countless hours and also provide valuable data that you need to increase sales on your site. Just before we get into the video, I want to put you into context. This is a scraper that we have built for one of our clients at Flowhog. We saw how powerful it was for them that we decided to share a version with you so you can also use it. So the code is fully open source. You will find it in the description. And this is what we do at Flowhog. We build practical AI solutions that solve real problems for SMEs. So if you're watching this video and it sparks you an idea of how you can apply this to your business, or maybe you're looking to integrate other type of systems, I totally encourage you to book a free consultation in our website, flowhog.com, and we'll be happy to help you. Alright, so just before we get into the code and the how to actually run this program, let's have a look at the different parts of the system. And as you can tell from the diagram, I'm not a professional designer, but I've tried my best. Okay, let's have a look. First of all, the system accepts as an input a website URL, okay? And immediately what we are going to do is we're going to convert the HTML of the website to Markdown format. So for those of you that don't know what Markdown format is, I have this image here that clearly represents the difference. And as you can see, it's way easier to understand Markdown versus HTML from a human point of view. Having said this, the reason we are using Markdown and not HTML is not because an agent cannot understand HTML, because it can perfectly understand it, but it's more about reducing the context that we are sending to the agent. Because in the end, the HTML normally contains a lot of information regarding website structure that and format that we don't necessarily want the agent to know. For example, it will contain a lot of classes regarding CSS, etc. So we are going to do this using a library called Crawl4AI. It's a very popular library nowadays to do scraping and to convert these websites into a format that LLMs can understand, such as Markdown. And then we get to the interesting part of the system, and this is our agentic system that will be composed of 3 different agents. Okay, I will later get into this, but let me explain you how the flow ends. So basically, after going into the agentic system, we will receive an output, and in this case, what we want to extract from the original website are 2 things. Okay, first of all, we want to know the different product variants that we can purchase. So imagine that you can purchase like these chairs in different colors. So we want to know that, and we want to extract technical specifications. Okay, and finally, we're going to do some post-processing, and we are going to put all this information into a nicely organized format inside a CSV file. What happens here? The main issue when extracting product specifications is that normally these specifications are contained within a PDF link inside the target website. Okay, and the same happens with images. There are plenty of times where images contain information that is not actually written in the product description. So I have these 2 examples here that clearly represent this. So for example, we have this chair, okay, and we have here some features. We can extract some specifications from here, such as, the chair weighs 25 kilos, etc. But if we then go to this technical file, we can see that there's additional information, and actually that it's not that easy to extract, because as you see, it's kind of is represented with logos and icons. And for example, we have the engine power, the battery power, how much weight can the chair withstand, and also the material. Okay. And so this is the first use case where if we use a traditional scraper, we wouldn't be able to extract all this information. Okay. And then, for example, we have this other side that it has some technical specs within the images. Okay. So as you see here, the dimensions are in this image, and if they don't have this information in the product description, we would totally miss this data. The way the agentic system works is the following. So the main agent is responsible for getting the markdown and extracting this output. But what happens? We are going to tell him that at his disposal, he has two different tools. One tool that is able to extract for him product information from PDFs, and then a second tool that allows to extract technical specs from images. Okay, and the interesting thing here is that inside each tool, what we'll have is a completely isolated agent that will be responsible for that task in particular. Okay. And so at the end of the day, these three agents will be connected with each other, but they will not know about the existence of each other. And something that is also particularly interesting here is that, for example, we are going to use a GPT-4o mini model as the main agent, but to extract the information from PDFs and images, we are going to use the model 4o, because it's way cheaper than using a 4o mini when processing images. Okay, and that's it. Let's have a look at the code. Okay, so I'm here in the AI Agents tutorial folder. As I said, this is fully open source, and you'll have the link in the description. And here we are going to work within the e-commerce data scraper folder. We'll be following the same folder structure that we have used in the previous tutorials. Basically, we'll have the agents folder that contain the agentic system. Then we'll have the main PI file that will be responsible for executing the agent and also saving this information into the CSV file. And finally, we have the utils folder that will contain two different functions that will be responsible for organizing agent data within the different rows and columns of the CSV files. Beyond that, we'll have an env example file that, remember, you will have to copy this remit to .env and put your OpenAI API key. For the logfire token, you could either put it or not. It will help you for tracing purposes. So if you want to understand better what the agent is doing, I totally recommend you to create an account within Logfire and then use this token here. In my previous videos, I did this, so I will put the video over here and you can follow it. And then you'll have this product CSV file. This is the type of format that the system expects as input. And finally, and here you see it just contains an ID column and a URL column. And these are the different URLs that we will be processing. And finally, we have the results file that contains the final results. Note that here, when you pull the GitHub directory, this file will not be here. And once you execute the main file, this will be automatically generated. All right, so I suggest we get first to the interesting part of the demo. Since this is why you are here, you want to learn how to build agents. And here in the listing summarizer agent, we have the agentic system that is composed of the three different agents. Before we start, for building the agents, I'm using my favorite framework, as I've been doing in the previous tutorials, and this is Pydantic AI. As you can see here, we are defining some Pydantic classes, and this would be the output that we are going to expect for the system. So here we are telling, hey, we want to have like a class that it's called technical specification, and this class will have an attribute name and value, and these two attributes will have a maximum of 22 characters. So why I'm putting this here is just to add more complexity to the system, because this was a requirement from our end client, and this in the end made it a bit difficult to process some attributes, because you will find that there are a lot of attributes that are longer than 22 characters. But if you set this restriction, you will see that the agent is able to do some abbreviations whenever it is extracting some technical specifications. And it's quite interesting to see this back and forth. I will later show you what I'm talking about, but let's keep it, let's continue. Then we define the model. As I said, I'm going to use GPT-4o Mini for the main agent. And here I have the system prompt. I'm just telling him that his job is to extract technical specifications, that the content will be in Markdown format, and I'm explaining a bit what a variant is and what a technical specification is. This is important when doing this prompt engineering, because if you don't provide examples and you don't clearly specify what's the technical specification and what's the variation, the agent will try to do whatever he can, and very likely he will extract things that are not that relevant for you. Here I'm explaining a bit the type of format that I'm expecting. So beyond this output that I'm specifying in terms of structure, I want him, for example, to put the units of measurement within the name of the technical specification instead of the value of the technical specification. So these are all the different type of things that you have to explicitly mention. This is not something that you can get it at the first time you try the agent. So it's a matter of iteration. You keep trying the agent, you see like some things that it's not doing properly, and from there you keep adding all the different details that you want. All right, I'm defining the main agent. I'm just saying, hey, please use this model for O Mini. A system prompt, use this prompt, and the output type that I'm expecting is a list of variant products. And here, as variant, I've defined that basically it contains a list of technical specifications. And watch out, because here I'm specifying a list of variants. So in the end, I will have a list of variants that within each variant we have a list of specifications. Okay, and just to prevent the agent from entering into an endless loop and to consume a lot of tokens, I've set here a safety measure of 3 retries. What it means is the agent will try to perform the job maximum 3 times. And this is something that it's very particular for the Pydantic AI framework, because the way it works is the agent is given the prompt, is given some input, and it tries to perform the job. And if something goes wrong, the framework is going to throw an exception that is called a model retry, and the agent will try again. And if something goes wrong again, the framework will throw again the same exception. What's the typical scenario where this happens and that the agent can get into an endless loop? Normally is when you are trying to force the agent to come up with an output that he cannot generate. For example, in this case, by setting this max length, it could be, for example, that there's an attribute that it's called, I don't know, maximum weight supported by user. And the agent, this is more than 22 characters, and the agent doesn't find a way to shorten this attribute to less than 22 characters. It will keep trying and trying and trying, and at some point it's just an endless loop. And when he tries 3 times, then this will throw an error, okay? And finally, we come to the 2 different agents that we have seen in the diagram. On one hand, we have the extract PDF information, and then the extract image description. So here, it's very important to see the 2 perspectives. So from the main agent perspective, the agent just sees 2 tools. One tool called extract PDF information, that is used to extracting technical information specifications from a PDF, and it accepts a PDF URL. And then a tool that is called extract image description, that extracts technical specifications from an image and accepts an image URL. Okay, so this is all the stuff that the agent sees, the main agent sees. Okay, so in the prompt, what we are telling him is, please, if you find that inside the markdown of the website there are some images that you think could contain technical specifications, please use the extract image description tool. On the other hand, if you see like a PDF that contain technical specifications, use the extract PDF information tool. And what happens when using Markdown format? Normally the links contains, well, you could see like the alt tag of the link. So for example, imagine that we have a PDF that is like a technical file that, as we have seen before, very likely in Markdown format you will have that the link it's within a text called technical file. That's why the agent knows that this link potentially could have the technical specs that we are looking for, and he will use these tools. So this is the main agent perspective, okay? And then if we get into the tools itself, we see that for the extract PDF information, we are defining again another agent, and then we're going to run this agent here, agent run. If the document contains technical specifications, extract them, otherwise return non-technical specifications, etc. And it returns the output, okay? What we are doing here is some kind of logic to prevent some errors. So for example, there are plenty of links that contains PDF and they do not end with .pdf. So when this happens, Pedantic AI framework throws an error because it's expecting to end with PDF. In this logic, what we are doing is we are taking these links that do not contain the PDF extension, and then we are converting them to bytes. And with this, we are able to process the PDF, okay? And similar for the extract image description, we are defining an agent, GPT-4o, and we are telling, hey, if the image contains technical specifications, extract them, otherwise return non-technical specifications in the image. And that's it. So this is how we define like a 3-agent system within Pedantic AI. And this is why I like this framework so much, because it's quite low level and it gives you a lot of ways to customize the agentic system the way you want. Something particular here as well, as you can notice, is the retries. For each tool, we're going to set a retries of maximum of 15 for the PDFs, and then 20 for the images. What happens here? Similar as we have seen during the main agent definition, there's another scenario where the agent can get into an endless loop that we need to consider. And this is when the agent keeps calling the same tool multiple times, expecting the tool to return something else, but the tool is returning all the time the same. So in this particular scenario, when could this happen? For example, imagine that we have a website that contains 30 images, and then the agent, he will use the tool 30 times. At the end, this is going to be extremely token consuming, so we'll have to pay a lot of money for this, and very likely if you have processed 7 images and the agent has not been able to find technical specs within those images, very likely the remaining ones are not going to have any more technical spec. Okay, this is why we want to set like the safety margin. So if the agent tries to use this tool 20 times, when it tries 21 times, this will throw an error and the agent will stop executing. All right, and that's it. So this is the agentic system. This is the block that we saw that has 3 agents. And now we need a way to execute this block, get the output, and put it in the CSV file. Let's get now to see the main PI file. This is the file that will be used to execute our system. So in this file, we'll have 4 functions, but the most important one is the process URL function. Why I'm saying this is because in this function here, we are taking a URL, we are scraping a website, we are converting this website to Markdown format, and we are using the agentic system to process the Markdown format and extracting the different variants of the website. The other functions that we will be seeing either in the main PI file and also the utils file are more related to getting this information from the technical specs returned by the agent and organize it in a way that it's properly represented in the CSV file. This is more traditional software development. This is why the interesting part is here, okay? So let's have a look at it. We just print a log, we just check if the URL that we are receiving is a valid one, and then here we are using Crawl for AI. I do not want to get too much in detail about Crawl for AI since I already did another video that I will leave it here. In this video, you will see how to build a more advanced scraper using Crawl for AI. So if you are more interested in these topics, just watch this video. But here, I'm just using Crawl for AI to crawl the URL. We are storing the result in this variable. And then we are running the agent that we defined before with this function, agent.run. We are passing the result as markdown to the agent. And then we are setting some usage limits. We are telling the agent that maximum he can call the OpenAI API 30 times. So how does these usage limits work? Whenever there's a new call to the OpenAI model, this counts as one. Whenever the agent is calling a tool, this is a second call. Whenever the tool is passing back the result of the tool to the agent, this is another call. Whenever the agent is trying to provide an output and the output doesn't follow the format that we defined in the parentic class, this will count as another retry. This is important to understand because otherwise it's so easy to get into limits and not being able to clearly know why this is happening. Okay, so this function will return the specifications as variant format. Remember we defined here, okay? And then we have like the other functions. We have this function that just loads data from both the result CSV file and product CSV file. And here we want to know what are the product IDs that are already in the result CSV file. So this way, whenever we resume execution, we do not duplicate already processed products. Then we are doing this process row that we will be using the process URL, and then we will pass this process URL to a second function called process variants that we will later see, that will be responsible for putting these spec results into the format that we want in the Excel file, okay? And finally, we are using the main PI function that just accepts an input file, the product CSV file, and generates the output file in this path that we define here. And that's it. Here we are just doing some iterations row by row, and we store the data to the new CSV file. Now, the last part of this system, it's these functions that converts all the output of the agent into the format that we want in the CSV file. Let me put here an example of CSV file, so you will have a better understanding of how does this work. All right, so I have here this file. This is the normal input. These functions, what they are doing is, if we are just detecting there's one variant, so if this, remember that the agent is going to return a list of variants, okay? So if the length it's only one, we are going to set this type column to simple. We're just going to print all the attributes in the following way: attribute one name, attribute one value, attribute two name, attribute two value, until we reach the end. And on the other hand, if we detect that the agent is returning a list of variants that has length higher than one, it means that it has detected that you can purchase the product in different formats. Then we will set this type column to variable. We will print all the different attributes, but then inside each variation, we'll just print the attribute that changes within variants. So as you see here, the color, this is a product that can have two types of colors, either gris and turquesa. Okay, this is Spanish because I think this web page it's in Spanish, some parts of it. And that's it. Also, another particularity of this system is in the main row, whenever there's an attribute that changes within variations, here we'll have them all together, just separated by commas, okay? So in the end, this is something very particular to the client use case that we have built, but you can paste this information here the way you want. So let's go back to our code. In the utils file, we have these two functions, but the main one is process variants, data set. Basically, we take this list of variants. First of all, we create a parent row that contains the ID and also the type of the product, whether it's variable or simple. If there are multiple values, we are just combining them with a comma in between. then generate the different variations. This is called like the child rows. So if we detect that there are multiple variations and within each variation there are attributes that change, we only put the attribute that change, and the remaining ones that stay the same, we do not modify them. I'm now going to show you how you can execute the code, and we'll have a look at the results. And also I'm going to show you how you can trace the agent with Logfire, so this way you understand what the agent is doing behind the scenes. Let's now run the agent. I have this README file here. I will put it inside the folder. So there are all the instructions that you have to follow to run the agent. I'm going to delete my virtual environment, so this way I start from scratch and you can follow exactly the same steps that I'm doing in this tutorial. Just remember that you will have to copy this end file to your .m file and put here your OpenAI keys and Logfire tokens. All right, so let's follow the README. First of all, we'll have to create an environment. Let's do this. Now let's install the dependencies. Just type pip install requirements. This will take a bit. Okay, it seems that... All right, so first of all, make sure that you are within the e-commerce data scraper folder, because if you are in the AI agents tutorials folder, you will not install the dependencies that we want, okay? So let's do it here again. Pip install requirements. All right, this will take some minutes. And once this finishes, we'll have to run this command, crawl for AI setup. Okay, here in my case, I created the virtual environment in the AI agents tutorials level, but normally you would create this inside the e-commerce data scraper. Okay, still doesn't make that much difference. All right, so we have crawl for AI properly installed and configured. I have now here this file with some examples that we are going to process. Let me delete this resource file. So this way we start from scratch. And now we just need to run the Python scraper. So this one. Okay, in this here, it's just Python. Since I'm already in the e-commerce data scraper folder, I will just run main PI. Okay, there was no output file found, and now it's starting from scratch. And now here we'll see some logs, like first of all, it's scraping the first URL. The agent, it's calling all these different tools. It seems that there are no specifications within the different images. The PDF contained some specifications, okay? And that's it. Now the first product is processed. And now this will get into a loop until all the different products that we have here are processed. And here in the results CSV file, it will be continuously updated until we have all the products. I will now pause the video here and I will resume once it has finished. Nice, so the agent now finished executing and it's time to see the results. So I have them open here. And if we pay closer attention to the results, we already see that we have some errors, okay? And this is totally fine. If you want to build systems with AI agents, you have to get used to it. So in this part of the video, I'm going to show you how you can, first of all, understand what's going behind the scenes and what are the type of errors that are happening, and then how to fix them, okay? So the first errors that we have here, we have some kind of post-processing errors. As you see, the name and values of the headers are not properly populated. We're not able to get the 10th attribute and the other ones. And finally, also, we have a column where we are linking the different variations to the main product ID. For these two types of errors, we will not cover them here because this is just a matter of coding. What is important though is, first of all, to understand why we have this error here, exceeded maximum retries for result validation. And finally, if you pay closer attention to the last two products, we also have some errors because, as you see, the agent has detected that there are some variations, but in the Excel file, we do not have any attribute value that it's changing. If you are at this point and you have not set up a monitoring tool like Logfire, you would be totally lost, or you would have to go through the logs here in the console. Let's 1 second. And try to understand what has been done, but this is a nightmare. And also these are some logs that you have to manually print. So the proper way to do it is to set up Logfire or another observability tool. And then you will be able to understand what are the different tool executions that has been done, how the agent has replied, what the agent has tried to do, and this will help us to understand what's going on. Let's first have a look at the first product to see if it has been processed properly. So is this page. If we go to Logfire, here we will have the different executions. So you see we have 9 executions, one for each product, and we are able to see what the agent has done. So we see that first of all we put the system prompt, then the agent has called these different tools. So it's around 9 tools it has called, one for PDF information and 8 for images. And actually we can see the URLs that he has detected from the markdown. So if we go down, actually here we see that the extract PDF information has returned the following information: model, motor power, battery, blah, 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 blah. Okay. So in the end, this tool, as we saw behind the scenes, there's another agent. So actually, if we go here on the left hand side of the panel, we can enlarge this tool's execution. And for example, if we go to the images and we open this, the agent has detected this link that contains these images and has used the extract image description tool, but nothing has been detected as technical description. Okay. And we can go image by image, tool by tool execution, and we see the image and we see what the tool returns. That again, inside this image description tool, there's this agent that takes the image, tries to extract technical specifications, and returns the information. In any case, let's go to the extract PDF information and look here. The agent has used this tool. Actually, we are seeing the execution of the agent within the tool. So the system prompt for the agent was this one: if the document contains technical specifications, extracts them, and then we pass the PDF itself. And in this case, this PDF is this one that I've also shown you before. And look that this agent has been able to detect all this information over here. Let's have a look. So model, motor power, 24 volts, 25, 250 watts. Okay, this one. We have 2 batteries. Okay, let me put this over here on the left. All right. We see maximum speed, 25 kilometers. Here we see an error. It has misunderstood this icon by speed. Instead of having 25 kilograms as weight of the chair, it has detected that it's 25 kilometers hours. Weight capacity, it's 150 kilograms. Material, aluminum, folding, yes, etc. So as you see, the scraper itself is super powerful because it's able to process all these icons that otherwise would be impossible to get this information. Still, it's very important to have these tools like Logfire to understand what's going on behind the scenes. This is an error that it's hard to fix because it's just an interpretation of the model, but still you're aware that this error is happening. Let's go back to the final output of the agent. So if I open this, we see the tool calls, we see that the different tool returns. So this was the last thing that we were seeing. And then with this information, now this agent will try to generate the final output. So here, color black, weight, width, turning radius, wheel size, max speed, weight cap. That this max speed it's wrong, but at least we know where does this max speed comes from. And finally, if we go to the Excel file, we see all this information put over here: width, wheel size, weight cap, etc. So this was this first product. Let's go to the second one to see if there's something interesting to see over here. Let me open the example. This is the second chair. Again, it's quite similar to the previous one. We have a similar PDF. And here at the end, we see that we have some technical specs. So this is very important in this case because the technical specs are within the PDF. There are more technical specs than before. We have some of them here, but anyways, the agent will try to gather the information from both sources. Let's see what it has done. First of all, it has called 7 tools, okay? Same as before. First of all, it calls the extract PDF information, that this will return all these specifications within the PDF. Let's put it on the left again. We see specifications: motor power, batteries, 12 amperes hour, 24 volts, okay? With battery. So in this case, it has been able to properly recognize that this is weight and is not speed, maximum user weight, material, and finally we have some additional technical details, that these are all the details that are over here. This is in Spanish, but it's the same. Seat width, ancho del asiento, backrest width, and you can go on and go on, okay? So now, the agent has called this PDF information that behind the scenes it's using the sub agent that processes PDFs, and it has returned all this information. Then it has called the agent to process images around 6 times, and here again we can see like what images are being passed to this agent. You see it, and all the times the agent is returning no technical specifications in the image because there are no specifications there. Okay, you grasp the idea. All right, so if we go back to the summary of the execution, we see something interesting, and is that after receiving the information from the tools, the agent tries to generate the output, that remember it's the list of variants, so in this case we only have one variant, but he's getting some errors. It has 3 validation errors. Basically it seems that he's using an attribute called effective sitting width, that it's more than 22 characters, depth without a footrest more than 22 characters, and depth with footrest more than 22 characters. So here the agent will try to generate the same output fixing this. The agent tries again, and here it has tried to make the attributes a bit shorter, depth with footrest. Okay, instead of footrest, it has put with or without foot. And finally, this result matches our expected output, that is less than 22 characters. Here we already see that in the third execution, that this was if we go back to the Excel file, this was this ID here. We have printed an error called exceeded maximum retries for result validation. It has happened exactly the same. Let's open this link quickly. And again, it's the same share provider. Then the technical information is within these PDFs. We have these icons, some things here. And actually here, super interesting because it seems that we have 2 colors, okay? Color turquesa and gris anthracita. And we have here the 2 references. So actually you can buy this product in 2 types, okay? Let's try to understand what has happened here. First of all, we see that the agent, if we open this, has called 7 tools, 6 tools to extract image description, 1 to extract PDF information. Again, let's have a look at what the extract PDF information has extracted. Weight, maximum user weight, color variants, folding. Well, it has extracted a lot of information, and here it has extracted 2 variants, gris anthracita and turquoise. And now if we have a look at what the main agent has decided to do, so we have 2 variants with 19 items each variant, 19 technical attributes. And if we open them, actually the variant the attribute that changes is the color, anthracita and turquoise. The agent is able to remember that you have told him to put the units of measurement in the name within parentheses. It's doing quite a nice job. The only thing is that since we are forcing the agent to use less than 22 characters, there are some attributes that have some issues because they are longer than 22 characters. Depth without footrest, depth with... Okay, it's the same attribute, but since we have 2 variants, within each variant it's making the same mistake. Now the Pydantic AI framework is prompting the agent to retry again, but unfortunately the agent is making the same mistake again. And now we automatically prompt the model to retry. And since this is the 3rd time, remember that if we go to the agent, 1 second, here, we have said that it can have a maximum of 3 retries when trying to generate the output. Here then, this has thrown an exception, and this is what we are logging here. What could we do in this case? We have several options. First option is just removing this constraint here, and then the agent will just print the attributes as they are, as he has done in the first iteration, and this will be accepted by the model. Second thing is we can tell the agent to omit the attributes that has some error. Finally, we can be more aggressive in the prompt and trying to tell him, hey, just abbreviate as much as you can. The problem though is that the agent is already generating a huge output. We are talking around 40 attributes. So the context, it's becoming too big for this model. And now let's proceed to see let's see more products. For example, let's have a look at this one. So Karma Mobility. Let's see. Okay. So here, this is a different page. And here the thing is that the specs are in this table. And it has around 6 models. And each model is changing some attributes. So let's have a look at the Excel file to see if the agent has been able to get these attributes right. So first of all, we have here 6 different variations. And it seems that the attribute that changes normally it's the ancho asiento. This is like the seat depth. The wheels also change. Chair weight also changes. Let's see. Yeah, we have it here. So we have, for example, armrest weight is 46.53. It's all the same. We have back height. It's 43.51. It's this one. It's stable. Chair weight. So we see here that in the parent, it has put all the different values. So we see 3.8, 14.1, 15.3, and 16.9. And actually, you see here that for each variant, it's putting the attributes as it is expected. Folded width in centimeters, it's 31. Folded width, 31. And here, rear wheels, we have different options, 7 per 14 inches and 7 per 24 inches. So we see 3 models with 7.14 and 3 last models with 7.24. Okay, so you get the idea. This performance was quite solid actually. And still total length as well. Okay, it has performed quite well here. Let's still see what the agent has done, and so we have a better understanding. So we have 10 tools that has been run, basically images. Okay, let's see to the summary what these images have returned. Okay, so as we see, almost all the images have returned like no specifications except one, this one. There's one that has returned a maximum load capacity of 130. And it's I think it's this one. Let's see. Not this one. Oh no, yeah, it's this one. Wow, look at this. This is a very excellent use case to display how powerful this agent can be. Here the agent has been able to read this sticker that it's written in, I think it's Chinese or Japanese, and it has been able to translate it to maximum load capacity. So then the final agent, the main agent, will use this information to also generate the expected output. So in this case, we have 6 technical specs, like the 6 different models. We start from 0 and with 12 values each. This is a very solid scenario. All right, let's proceed. Let's go to the next one. All right, we have this one here. Let's see if there's something interesting. All right, just normal chair. I think all the information is over here. In this case, it has extracted all the information from the text there. So for example, frame mat, folding size. For example, weights, it's 15.5 kilos. Battery, it's 12 amperes. Hours, let's go back. Weights is 15.5 and battery should be over here. Battery type, 11.6 ampere. Okay, 11.6 instead of 12. Maybe there's some. Okay, there are some specs here. Okay, it's taking it from here, right? This is interesting to see because these pages have some contradictions, but the agent still is clever enough to get those that are the most important ones. So I think in this case, the agent has taken almost all the information from here. So it's quite good. Let's try to see the final ones, the ones that are, or this one as well. Let's see this one. In the end, we are going to see all of them. Okay, here, this is an interesting one. Okay, let's see. The agent seems, it has detected like 3 types of variations. You can have a drive range of 18 kilometers, 40 kilometers, 50 kilometers, seat depth 38, 43, 52, warranty 12 months, 36 months. Okay, or meters, I'm not sure what's that. Let's have a look at it. Actually, you could here choose controller side, left or right. I think the agent has not detected this. Let's see in the Excel. No, in this case the agent has not detected this, but it has detected the other ones. Seat depth 38, 43, 52, batteries 30, 18, 40, 15, 12 months, 36 months. Alright, let's see. Let me put it here so we can understand a bit better what's going on. So it has been properly extracted. Drive range 18, 40, 50 as well. Seat depth 38, 43, 52. Okay, quite good. The only thing it has missed the controller side. Having said this, in this case, it has assumed that 18 kilometers drive range, you can only have the 38 seat depth. This is something that you would have to do post-processing, very likely. You can either try to prompt the agent to do this out of the box, but since we want to have the different possibilities for each of these values, this would be 18 combinations, more or less. This is a lot. Normally you would have to do this programmatically. I just want to be transparent with you, like with what's possible, what are some limitations that we are facing. This way you understand a bit what's the tricky part when building these type of systems and how you can fix them. Okay, we go to the final 2 errors. That remember that in these 2 products, despite the agent has detected some variations, we do not see like the child elements with what's the attribute that changes. So let's have a look here. I'm going to go to the page. Okay, this is the product itself. It's a bit tricky. First of all, I've included this product on purpose because I want to show you some stuff. First of all, we see that, for example, in this image, you have some dimensions, for example, but then if you go to these dimensions over here, they might change a bit, okay? So, for example, product size, it's 63, 93, 121, but here it's 48, 157, and 72, yeah. So as you see, even themselves, the attributes that they have in the images are different than the attributes that are in the specifications. But still, let's have a look at it and let's try to investigate what has happened here. So it's this, not the last one, but one before the last one. We see the agent has called 4 tools. It has tried to extract information from 3 images and from 1 PDF. And actually, let's make this bigger. Alright, so interesting. We have extracted from 2 different images these technical specs. So actually, if we open these tools, the second and the third one, okay, from the image, it has extracted that the width of the seat is 19 inches, 48 centimeters. Height 36, 91 centimeters, extended height 62, 157, depth of the seat 23.5, 70 with front and with back reflects to the wheels. This could be error prone because in the end, the main agent doesn't have the context that this is referring to the wheels, okay? But still, let's have a look. And then for this image, no technical specs. But for this one, okay, look, here it has taken some specifications, turn space from this image, that this image over here, it's okay, we have it here. It's like the dimensions of the stairs. And actually, if we go to the summary, we see here the stairs dimensions. It tries to generate, actually, let's see how much. Basically, it has detected two different products. It has detected the wheelchair itself, okay, and these are the attributes over here, as you see, and then it has detected the attributes for the stairs, turn space, stair distance, etc. What has happened is, when trying to post-process this information into the Excel file, it has detected that the two variations have some attributes that are not common, and this is why we have two variations, but then missing attributes. So this is an edge case, and it's interesting to see because this is something that you will find all the time. You cannot get the system to perform well on 100% of the cases, especially when we are talking about these edge cases. This is a matter of detecting what are edge cases and what's a normal case, right? Because if, for example, you are just parsing information from this site and like 90% of your cases have these issues that you have like these stairs or additional images, very likely you have to tweak your agent, for example, the prompt, specifically saying, hey, please detect that there might be some dimensions related to the space, etc. So please do not consider them, okay? On the other hand, if this is just a minor case, it's not worth it to have this information in the prompt, because otherwise the agent will stop generalizing and it will do well these two cases, but the other ones that represent the 90% of the cases will not work well. I wanted to show you all the issues that you can encounter while building this type of scrapers, or also this applies to any type of agent. Many tutorials out there always present the happy path and they provide very favorable conditions to the agent. The reality is that when you're putting these systems into production, you will always find these edge cases and you need to find a way to fix them. All right, and that's it. With just a few hundred lines of Python, we can have a script that is driven by AI agents and that can automate a critical part of our business. I hope this tutorial has been helpful for you and it has shown you a bit how powerful it can be to integrate AI agents within your business. If you enjoyed this video, please give a like and subscribe. I will keep uploading videos of the different use cases that we are integrating for our clients at Flowhog. So if you want to stay updated about the latest AI trends and how companies are using AI to bring their businesses to the next level, this is the channel for you. Also, if you have some doubts or you want to discuss about AI agents, just reach out to me either on LinkedIn or at Flowhog, and I'm always happy to chat with you. See you in the next one.